can see here, doing some multiplying and dividing with scientific notation. From here forward, we can call it Sn. You can see the rules here given to you algebraically, right? If you multiply two powers with the same base, you add the exponents. The x and y get added, x plus y. If you're dividing two powers with the same base, you subtract the exponents. If you're raising a power to another power, you multiply the exponents. Again, you can look these over as for as long as you need to. Raising anything to the power of 0, you get 1. And then if you have a negative exponent, you can move that, whatever base has a negative exponent, you can move up or down as in a fraction to make the exponent turn positive. Again, that's if you move an exponent up or down, wherever it's at. If you move it to the other spot in a fraction, the exponent will change sign. So, I'm going to get into some of these. Anything to the 0 power equals 1, so 7 to the 0 power equals 1. Right here, pi to the 0 power, that's still 1, even though we don't even know where pi ends. Once we raise it to the 0 power, it's 1. Here, I have negative 5, the whole negative 5 being raised to the 0 power, so that's 1. Technically, when you remove the exponent, when you remove the parentheses, you have this different situation. Like, we've talked about this in a previous lesson. When you remove the parentheses, you have basically thought process becomes, okay, this is 5 to the 0 power, and the negative comes along for the ride because it doesn't have parentheses. 8 to the negative second power, you're going to want to basically put that 8 on the bottom of the fraction. Originally, you could think of this as over 1. Any value that's not a fraction can be put over 1. So when you move the power with the negative exponent, when you move that down, the exponent becomes positive. And 8 squared is 8 times 8, so you could call that 1/64. I suppose as long as you know how to make the exponent positive, that's the main point of this skill, but may as well multiply out the small ones. 5 to the negative third is 1 over 5 to the third again. If you put it over 1, moving it down is what makes the negative exponent turn positive. That's all good if you want to multiply it out. 1 over 125, right? 5 times 5 times 5. Next one, 7 to the negative first power is 1 over 7 to the first power, which is aka 1/7. 19 to the 0 power, right? Anything to the 0 power is 1. Careful with this one. This is 3 times pi to the 0, which is aka 3 times 1. In this one, the pi to the 0 is, pi is the only number getting raised to 0. So then that's 1, but then 3 times 1 is 3. Careful with something like that. No parentheses here means the negative will come along for the ride, right? Anything to the 0 power is 1, no parentheses, the negative comes along for the ride, and it's going to become 1 over 9 to the second, right? Moving it down, if you think of it as over 1, moving it down is what makes the negative exponent turn positive. And 9 squared is 81, so 1 over 81 there. Careful with this next one. Only the power that has, or should I say, only the base that has a negative exponent moves, meaning only the x moves. If this was over 1, the 6 stays on top and the x moves down to make the exponent turn positive. This one, 12 to the negative first power, that's just going to be 1/12, 1 over 12. Just a quick note here, anytime my scientific notation has positive numbers for exponents, I'm going to get a really large number, right? So a really large number would associate with scientific notation exponents being positive. And then if the exponents are negative, we're getting some really low value or tiny numbers, so to speak. So negative exponents, these numbers are going to be tiny. Positive exponents numbers will be large, which aka means, in this case, I'm going to, again, since I have a positive exponent, I'm going to make 2.6 larger. Remember, positive exponents mean numbers are pretty big. So I got to move the decimal, in this case, 7 places. The exponent tells me that. 1, 2, 3, 4, 5, 6, 7. All these empty spots would just think of them as nothing, right? There's nothing in those spots, and the numeric, the number, we should say, that has nothing, right, or as its value is 0. So fill in nothing with nothing, aka 0, and we have 26,000,000,000. Just count backwards here to put commas. So 2.6 times 10 to the 7th is 26 million. This next one, it's times 10 to the -8th. Remember I said negative exponents will result in tiny numbers, meaning that 1.016 decimal moves 8 spaces but left. So 1, 2, 3, 4, 5, 6, 7, 8. And all those spaces I just moved get filled in with zeros, 7 zeros, and normally with scientific notation, well, I shouldn't say normally, but a lot of times, however many times I move my decimal, I'm going to have to fill in all those zeros, but normally it's like one less than the amount of spaces I moved it, meaning like I moved this decimal 7 spaces, but I only needed to put 6 zeros. I moved this decimal 8 spaces, but I only put 7 zeros because I had to, one of those spaces is to move past the original number. So just something I might think of, because like right here, instead of trying to see how many times I moved it, I simply need to know that I'm going to move the decimal once, and after that 7 more times, so I got to have 7 zeros. So anyhow, 0.0000000, again, knowing I need 7 zeros, 1016 is a tiny number as promised. So next, 7.4 times 10 to the 9th. Remember, that's a positive exponent, so 7.4, I'm going to move the decimal 9 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I really just know that I'm going to end up adding 8 zeros because I moved 1 space, and then all the rest of the spaces, nothing was there. So 8 more spaces of zeros. 1, 2, 3, 4, 5, 6, 7, 8. And that number, what is that number? 7,400,000,000. Looks like 7,400,000,000. Next one has a negative exponent, so I'm getting, as I get better at this, maybe I'll just know that I'm going to move this 6 spaces. So once I move it 1 space, I've got to move it 5 more times, right? And that's going to be 5 zeros out front. 1, 2, 3, 4, 5, 3, 0, 1, 7. So again, maybe I don't need to show every time I move the decimal. I just got to have a clue how many zeros I need. Okay guys, so next problem here. Just quick note, and when I change these numbers to scientific notation, the rule is that the first number has to be either greater than 1 or less than 10, meaning like the first one, I'm going to have to move the decimal until like 1, let me count, 1, 2, 3, 4, 5, 6. I got to move it 6 spaces. Reason being, that'll leave me at 4.6. And the number that I use out front has to be greater than 1 and less than 10. So the fact that it has to be greater than 1 and less than 10 tells me where my decimal stops moving. Anyhow, I had to move it 6 spaces, meaning it'll be 10 to the 6th, right? The reason I know it's a positive 6 is because that's a huge number, so I know that a huge number should have a positive exponent. On this one, I'm going to move my decimal place, let's see, 1, 2, 3, 4 times, and I know I need to stop there because if I move it 4 times, it ends up 2.3, which again is greater than 1 and less than 10. The number out front for scientific notation is supposed to be, again, between 1 and 10, basically. So that kind of tells me where my decimal stops, and when I know where my decimal stops, I know how many spaces it moved. Again, this one was 1, 2, 3, 4 spaces, but remember, that's a tiny number right there. That's a very, good amount of decimal places, so tiny number, negative exponent. I moved it 4 places, but negative exponent because it's a tiny number. Next, I have 7,410,000,000. If there's no decimal, it's on the left here, and I have to move it all the way. 2, 3, 4, 5, 6, 7, 8. I have to move it 9 places to essentially get 7.41, which is, again, greater than 1 and less than 10. If the number has to be greater than 1 and less than 10, then you know where to stop. So we moved that decimal 9 places, and that means this is going to be times 10 to the 9th power. So these powers of 10, all they really do is move decimals, right? If you're multiplying by a positive power of 10, the decimal is going to move away to the right. If you're multiplying by a negative power of 10, the decimal would move to the left. So anyhow, one more tiny number, right? This tiny number will definitely end with a, times 10 to a negative power. I just don't know what it is yet because I haven't counted. 1, 2, 3, 4, 5, 6, 7, 8. I need to move the decimal 8 places to get 9.2. And again, since I moved it 8 places, and 8 goes here, remember it's a negative 8 because that number originally was tiny. Okay, so this last little section, guys, it's numbers that are in scientific notation being multiplied or divided. If you're multiplying, here's what you're going to do. You're going to multiply the decimal numbers. So 3.4 times 2, that's going to be 6.8. And you're going to just add the exponents on the powers of 10. So 10 to the 9th times 10 to the negative 5th. I'm just going to add the 9 plus the negative 5. Oh, and sorry, I didn't show it, but I did multiply 3.4 times 2, right, to get the 6.8. Again, that's multiply the decimal numbers. 3.4 times 2 is 6.8. And add the exponents. 9 plus negative 5, that's 9 minus 5, that's 4. So this is one way to do these, where you do this, and then 6.8 times 10 to the 4th is what I'll get. And then it actually does say to give the answer in decimal notation. So I'm going to move this 4 spaces to the right because it's a positive exponent. So 6, 8. I'll have to add in 2 zeros. If I move the decimal 4 spaces to the right, I'd move it 1 space, and then I'd have to fill in 2, or wait, that's 1 space. I have to fill in 3 zeros. I messed that up. We fixed that. So 68,000. Next, I have this one. Again, it would be basically 8.4. I would divide that by 4. I'd do that. And then the 10 to the negative 7th times 10 to the negative 4th would be 10 to the negative 7th minus a negative 4. So again, subtracting the exponents when I'm dividing scientific notation. I'm subtracting the exponents, so negative 7 minus negative 4 is plus 4. 8.4 divided by 4 is 2.1. So 2.1 times 10 to the negative 7 plus 4 is negative 3. Since the exponent is negative, I can move the decimal 3 spaces to the left. So again, 1, 2, 3. Fill in 2 zeros, right? 0.0021. So I'm making these into decimals. I did write to convert them to back to scientific notation. That would be if necessary, but we're not going to do that. We're just going to make them decimals because that's what it says. So the next one, again, it would be 1.3, right? You multiply the decimal numbers, 1.3 times 4, and you add the exponents. Again, if you're multiplying numbers in scientific notation, you can multiply the decimals and add the exponents. So 4 times 1.3. 5.2 times 10 to the 7 plus negative 2, that's 7 minus 2, that's 5. It's positive 5, so I can move this decimal 5 spaces to the right. So move it 1 space, and then 4 more spaces means 4 zeros, so 5, 2, 2, 3, 4. Looks like we got 520,000 on that one. And then this last one, 6.9 divided by 3, what's that going to be? That's going to be 2.1, right? Or wait, sorry, 2.3. 2.3. I mean, have a calculator handy. It's getting late here. I'm not sure. Yeah, 2.3, and then it's going to be times 10 to the, subtract the exponents, negative 8 minus negative 2, so plus 2. Again, the 6.9 divided by 3, I just forgot to show that, but that's where the 2.3 came from. So you divide the decimal numbers, and you subtract the exponents if you're dividing numbers in scientific notation. So 2.3 times 10 to the negative 8 plus 2 is negative 6. So I'm going to move this decimal 6 spaces to the left. Remember, negative exponents will give you tiny numbers. Move it 1 space. If you move it 5 more spaces, that means you got to add 5 zeros in there. So 0.0000023. And all done. So hopefully that helps. Thanks for having a look.